Okay, welcome back. This is Review 8, our cumulative review for Lesson 32, which was graphing linear equations and the rectangular coordinate system. Okay, so for this review, we do not use a calculator. There are only 7 questions, and I'm going to just guide you through it with ease. And if you feel comfortable with all the problems, then just reminding you, you want to attempt the self-assessment on iTunes. And if you get 80% or more correct, you're ready to move to the next post. Okay, let's dive right in. Find the coordinates of the points shown on the graph over here and list them. All right, well, let's just talk about why they are what they are. So keyword coordinate. So coordinates are of the form x comma y. So let's go ahead and take a look at point A. Point A is located right here at origin. So I'm just going to talk you through it. So we know that origin is 0, 0 in terms of its x and y coordinate. Okay. Now let's go ahead and take a look at point B. Just find them in order. B is way over here, so I like to think of it as, left 7, so back here at -7 in the x direction and up nothing in the y direction. So -7 in the x direction and no vertical shift, so up 0 in the y direction. Okay, let's continue with that. For point C is located over here, so I like to think of it as over up, so over 6, or to the right 6 in the x direction, and up what appears to be 7. Oh, I just noticed, sorry about that, I just noticed something. That was tricky there. I just noticed the tick marks. I want to, and luckily I have the answer key too, it helped me, but I just noticed the tick marks. I wanted to show you that. Point B, that's tricky. If this is 7, I just noticed the grid. If this is 7, then this is actually, or a -7, then this is actually at 6.5, -6.5. So I did want to adjust that. I just saw that. So be careful of the tick marks. It's kind of a cool one. Got to zoom in to see it. But yeah, this is, it kind of goes 2, 4, 6, 8. So, -7 would be here. So this would actually be here at -6.5. Anyhow, so let's bear that in mind with when we find point C. So over 6, up something, and it does tend to land right there on 7. So you just got to kind of count the tick marks there to see if it lands perfectly at 7. So we'll call that one over 6, up 7, or 6, 7. All right, now let's be on the lookout for point D there. Point D is what appears to be back 1, meaning at -1. So back 1, up something, and I'm looking at the tick marks, it appears to be up at 3. So we'll call that left 1, or -1, up 3, in terms of its x and y coordinate. And again, I'm not even looking at the answer key until the end, but now I see that we're so far so good with the answer key. Trying not to look at the answer key and talk through it. Okay, point E, I'm back something and down something, right? So back 7 down what appears to be down at -7. So -7, -7. I'll just kind of check that with the answer key. Yep, so far so good. And point F, again, I'm trying not to look at the answer key. F resides right here on the y-axis, so we'll be 0, -2 in the y direction. So that's why F will be 0, -2 for its y coordinate. And that's matching. And last but not least is G. And if you think about point G, you're over 4 in the x direction, and down, the tick mark would have you there at 1, and down 1. So 4, -1 would make total sense for point G. And we got it. All right, so plotting points is one of the first tasks we have in that post and we get comfortable with. Let's head on to number 2. Graph this linear. Now we jump right into graphing linear equations, and it says by finding and plotting at least 3 ordered pair solutions. Well, like I said, I'm assuming you've been through all the guided notes for this, and you have the sort of the T-table under your belt. You know, you have ways of selecting ordered pairs. Now, if you did this on your own, you might not select the same 3 ordered pairs that I do. But one thing I like to do is I like to put 0 in for x, put 0 in for y, which is thereby actually finding the intercepts. And then I can figure out my 3rd ordered pair if I need to. So if I put 0 in for x, then 8 times 0 is 0, and I'm really looking at negative 4y equals 28, so y would have to be negative 7. And I'm just doing the mental math there. You could write it out if you like. If you put 0 in for y, then that'll go away, and x would have to be whatever 28 divided by 8 is, which isn't a whole number, but now we could look at some other ordered pairs that might satisfy it. And sometimes you just have to get creative. You know, you have to think about nice number combinations. Like, for example, if x was 1, what would y have to be to satisfy the statement? And like I said, you could write it out if you want to think about it. Like 8 times 1 minus 4 times something has to equal 28, right? Well, 8 times 1 is 8. So you'd have 8 minus 4y equals 28. So long story short, if you were going to solve that for y, so you'd have negative 4y equals, you know, deduct off the 8, equals 20. So therefore y would have to equal negative 5, right? So sometimes you play with the numbers until you get a nice little what's called a linear combination, a combination that works. So let me erase all that math there. We have 3 points. We can go ahead and plot them. Granted, the 1 is not, an integer. But let's go with the pretty points. So 0, negative 7. So let's see, 1, 2, 3, 4, 5. I'd have to extend this actually. 6. Let me scoot the let me scoot the answer key down and away. Should have made my grid bigger, I suppose. So negative 5, negative 6, negative 7. So 0, negative 7. I could have a point down there at 0, negative 7. And I'll grab this other one here, the 1, negative 5. So that's over 1, 1, 2, 3, 4, 5, down 5. 1, 2, 3, 4, 5. So that's right about here. Now, right with just that, I could go ahead and connect these dots, right? And since, 28 over 8, well, let's see, 8 goes into 28 3 times with 4 remaining, so 3.5. So even if you turn this into a decimal, you're looking at about 3.5. So 1, 2, 3, 4. So we're looking at about right here, right? So even if I take I call it the connect the dots tool, and just go ahead and let's say connect these dots, then I can go ahead and check the solution and it's true, I have the same thing here. I've got my y-intercept down here at 0, negative 7, and it does appear that I'm hitting here at 3.5. So it is matching up with the solution. All right, hope that helps. And like I said, the ordered pairs that I picked might not match the ordered pairs that you picked, but as long as you're ending up with ordered pairs that live along that line. Okay, let's try the next. Graph this linear equation. Now this one should be a little bit easier for us. Let's, I call it the T-table, XY table. Let's go ahead and find some nice little values there. Again, I'm going to do what I always do. I'm sort of going to target the intercepts because those are just usually helpful. So if I put 0 in for x, y would clearly have to be negative 1. And if I put 0 in for y, x would clearly have to be 1. Now, I did the mental math. If you want to write it out, physically put 0 in for x and think about what y would have to be a true statement. So it's like 0 minus what makes 1 will have to be -1. See? So that way you can think about why that ordered pair satisfies this. Okay? Now, here's a slick way to find a third ordered pair, right? So let's graph 0, -1. It's right here. And let's graph 1, 0. It's right here. And let's go ahead and connect the dots. Let's go ahead and connect the dots. Well, you're starting to see something. You know, you can rise and then run, and then rise and then run, and that would be a really neat way to get that next ordered pair, right? Because there's an infinite supply of ordered pairs that live along that line. And in fact, we can indicate that by putting arrows on the end. But if I had to grab a third ordered pair, now we know that's 2. What is the coordinates of that? 2, 1. Well, we also know that 2, 1 satisfies the equation, right? Is it true that 2 minus 1 makes 1? True, right? So we know that those ordered pairs live along that line. 1, 2, 3. All right? And we see it in the solution here. There's a 1, 0, there's 0, -1, and we see we are correct. All right, hope that helps. Now let's head to the next one. Complete each ordered pair solution. I just wanted to talk about if I give you an x, how will you find y? Well, you're going to have to plug 6 in for x and think about it, right? So 6 minus y makes 13, and literally solve it out, or just do the mental math. I'm going to solve it out. -y equals 7, therefore y must be -7. So when I complete that first ordered pair, it must be 6, -7. And we see that solution. Let's try it again. I'm going to do this in another color. So with this one, x is missing and y is given. So let me just highlight that. So now I have to take -6 and -6 and store that in for y and do a rewrite. So I'm actually going to, now that we're focusing on that next ordered pair, let me erase what I had before. Okay, so now I'm going to take -6, store that in for y, and do a rewrite. Okay, so x minus -6 has to equal 13. And then you just figure on what x would have to be. So you've got your double negative there, so x plus 6 has to equal 13. Therefore, x would have to be 7. And voila, x would have to be 7 when y is -6. So we figured on that. So a lot of people say, oops, sorry about my pen marks there. A lot of people say that that's just plug and chug. You plug in the given and solve for the unknown, which is very true. Let's try again. I'll do that in another color. Last one, we have a 0 for x, but we don't know the y. So let's take 0, zoop, put it in for x. Okay, so 0 minus something makes 13. What must that something be? Well, obviously -13, but if -y equals 13, then y must be -13. And voila, that's why we have -13 here. All right, hope that helps. So it's a lot of input-output. Again, if they give you the x, you got to figure the y. If they give you the y, you got to figure the x. And last one here, they give you the x, you got to figure the y. All right, let's try the next one. Graph this linear equation. Again, I'm going to resort to my lovely little xy table method. Again, I'm going to go with, putting zeros in for x and y respectively. So if I put 0 in for x, what will I get out for y? And I'll write that out for grins and giggles. So, 0 plus 7y equals 7. Therefore, 7y would equal 7. Therefore, y would have to be 1. in order for that to be a true statement. Okay? Now I'm going to erase my mental math there. Try the next one. If I put 0 in for y, what would x have to be? Well, x plus 7 times 0 would equal 7. Well, that'll just zero out, so x would have to be 7. Record. And then, you know, typically I like, even my live students, I ask them for 3 ordered pairs. Here we'll just go with the 2 ordered pairs for now, and we can find the third one if need be. So let's go ahead and plot. So 0, 1 is right here. 7, 0, 1, 2, 3, 4, 5, 6, 7 is out here. And I can do my lovely little connect the dots tool. Zoop. Okay. And like I said, if I was forced to find that third point, I could sort of do it graphically, you know, meaning I see here a rise of 1 and a run of 7. Well, I could repeat that pattern, right? I could go up 1 and back 7 and see where I land. So 1, 2, 3, 4, 5, 6, 7. I'd land back here, right? And I could continue connecting those dots. Okay? And obviously we could figure out the coordinates of that point as well. We'll put arrows on the end of our line. The coordinates of that point are obviously -7, 2. So if you think about it, I always check, does that satisfy the original equation? Is it true that -7 plus 7 times 2 makes 7? Does -7 plus 14 equal 7? Yep, it's true. So like I said, finding 1, 2, 3 ordered pairs isn't that bad. Okay? Oh, and it says identify the x and y intercepts. Well, let's lay a claim on them. This point here is obviously the y-intercept, so that's 0, 1. And again, I'm just going to reiterate y-int, y-intercept. And this point here, 7, 0, x-int, x-intercept. Okay, let's head to the next one. Oh, and obviously, I mean, I have the solution pasted down here. Okay. Number 6, either you might have it memorized that x equals -2 is a vertical line. So some people just go, okay, here's -1, here's -2, obviously here's origin. So some people just say, all right, I'm just going to shoot a vertical line, you know, right through -2 on the x-axis, right? You could do that by memorization, or you could go the old-fashioned way, which is still the table, but if you think about it, it says that x is -2. That means that x is -2 forever and for always, despite what y is. So it doesn't matter what y is, x is -2. And then when you go to plot those points, you'll see, okay, -2, 0, -2, 1, -2, -1, negative, you know, you start to see all those points, you know, live along that vertical line. Okay, and last but not least, you can probably guess y equals -3. If you have y equals a constant, you may have it memorized already that it's horizontal. So 1, 2, 3. We could just shoot a horizontal line right through, oops, my bad, it said -3. Sorry about that. Let me do the undo. There we go. I just forgot it said -3. So we'll go the other direction. -1, -2, -3. So we can just shoot that horizontal line through -3 on the y-axis. But you know, if you are more of a sort of linguistics type person, if you think about it, it makes sense because it says that y is -3 despite what x is. So x can vary and y is always negative 3. So even if you start to sketch out those points, okay, 1, negative 3, 2, negative 3, 3, negative 3, 0, negative 3, you start to see that all those points reside along that horizontal. All right, hope that helps. Let's see, I believe that was our last problem for Review 8. Yes, it was. So you're ready for your self-assessment if you understood all that. Good luck.